Hello and welcome everybody to the AI Agent Clinic. This is our first episode and it's a worldwide premiere. We're going to take your agents and refactor them for production. My name is Luis.
And I'm Jacob. Super excited to have you here for the first episode.
All right, we're going to be hanging out in the live chat right alongside with you. So we're going to answer any questions you might have throughout the broadcast. So don't be shy. Please go ahead and drop them in.
Yeah, and please stick around till the very end. We'll be doing a live technical Q&A, doing a behind the scenes code review. It's going to be a lot of fun. I think for now, let's roll the tape. I coded this in the evenings and weekends. I was blown away at how doable it was. If I can do it, anyone can do it.
You've already identified the one superpower you want to give your agent.
Okay, builders, your time starts now.
Okay, I don't know about you, but I gotta get set up. Let's plug in. And structured messaging is the best way to connect one system to another. And so I'm very, very proud of you, frankly, for
You should be proud of Gemini because
Time is up. No! Hands off keyboards.
I thought we were going to get this done in about 30 minutes.
I think the problem is I talk too much. Welcome to the AI Agent Clinic, where we work side by side to triage your broken builds, untangle your code, and help you get your agents production ready. Joining me in the clinic today is Jacob Badish. Jacob, welcome to the show.
Thanks, Luis. Appreciate the time. This is awesome.
So Jacob, if I understand correctly, you have no technical expertise, and yet you built an agent by yourself. Tell us about it.
Yeah, that's right. It's called Titanium, and I vibe coded this in the evenings and weekends. I was blown away at how doable it was. If I can do it, anyone can do it. What Titanium does is it finds certain executives at our customers and partners, figures out pain points that they're struggling with, challenges that their businesses are facing, and ties it back to strengths of Google's in ways that we can help them.
So it researches the customers?
Yep.
And then it generates what, an email?
It does, yeah. It provides research, messaging, and a really clean email. And again, it's really to save the executives time. I know that you're struggling with ABC. Google's really good at doing XYZ. Let's sit down and have a conversation. And it uses, I've actually hard-coded, this is probably not the best way to do it, but I've just hard-coded in about 10 case studies. So Google has all these public case studies. I picked 10 of them, and I was noticing that it would use the same data points in these emails and messaging, and it's probably not the best way to be doing that.
All right, so it sounds like you've already identified the one thing you want to give your agent. Let's elaborate on this. So if I understand correctly, Google has over 1,000, actually 1,600 case studies, and you want to be able to leverage those instead of the 12 or so hard-coded case studies that you have in there.
Yeah, exactly. It's a good tool that works for me. It's not really scalable. I can't roll this out to my team quite yet. And because of the limited case study set, it's not as robust as it could be, and I think if there's a way to dynamically do this and have it really understand the company that we're trying to work with and help tie it back to a really relevant case study, that's just a lot more valuable.
So now we know what you need to take this agent and release it to your colleagues and get it production ready.
Yeah.
So we've given ourselves 60 minutes to fix this agent and give it superpowers. All right, Frank, what do you think? Can we get started?
Okay, builders, your time starts now.
Okay, I don't know about you, but I gotta get set up. Yeah. Let's plug in.
You'll walk me through what we want to do.
That's right. Okay. I see that you have a function called orchestrate all. And what it looks like it does is that it goes through a loop where it goes through every company that you intend to target, right? It launches a set of parallel tasks.
Yep.
Wow.
Yep.
That is awesome. So you are actually performing what's called a fan out, where you are executing these research tasks not on a single company in sequence, so not one at a time, but you're actually researching multiple companies at the same time. Essentially, we can think of them as sub-agents, each one responsible for processing a single account and passing along certain information like who the customer is, what the SDK client is, and so forth and so on. So that's beautiful. And as it executes, you start collecting those results and you can assemble them.
Yeah, and this came about it would take 15 minutes to run originally. And so, and this is where I got so much better at working with Gemini and prompting, because you just go back and forth and like, how can we improve this? And it would say, this is a really rudimentary way to do this. We can do X, Y, Z. And I would, again, collaborate through, okay, let's try this idea. That sounds good. No, I don't want to do this. Rewrite the code, redeploy the code, test it. So it was all, I have like exponential back off. There's clever ways of interacting with the Gemini APIs. So it was able to build, again, it's a simple app, but there's a level of robustness that the AI has just taught me how to implement along the way.
I really love it. And the fact that you're throwing out terms like exponential backoff, it shows that you understand kind of what the challenge, the fundamental challenge was. And that is that, for example, calling LLMs sometimes is unreliable. It's an unfortunate fact of life, right? Sometimes you might get rate limited, or sometimes you might get, your Wi-Fi might disconnect or something like that. So building reliability into your agent is important.
All right, folks, 10 minutes past.
Already?
Okay.
Oh no. Okay, so we got to get started with the coding, but let's finish that section very quickly here. Okay, so I see here, this is the actual meat of this. This is how you call the model. And so once again, you're using the Gemini SDK to connect, and you're passing it along a configuration to use grounding with Google Search. Bravo on that. You also set the temperature low. This means that the model is going to generate less random answers, which is important for something that's factually grounded. So brilliant, love it. And if we scroll a little further up, we see, a function called verify intel. It is structured very similarly to the previous one. However, your prompt is basically kind of saying, hey, we're trying to ensure that we're not hallucinating. Well done, bravo, this is great. And I see it uses the same basic techniques as before. That's it. Oh, and here are your case studies. I see. All right, so let's go ahead and kind of think about what the next version should look like.
Okay.
If we think about the version 1 that exists today, you launch it, it's going to research a company, it's going to draft an email, it's going to verify everything, and then gives you the final content, right? When you're researching, you're also providing just this list, this hard-coded list of case studies. When you're developing an agent, it is absolutely perfectly a legitimate tactic to use the native SDK, such as the Gemini SDK or GenAI SDK that you're using today. However, it occurs to me that in order to set yourself up for success in the future for better performance out of your agent, it might make sense to shift over to a specialized SDK specifically designed for agents. And that would be the Agent Development Kit would be my recommendation. We move on to like a V2 plan that uses ADK, but it preserves the existing workflow, right? So it actually would replicate your V1 functionality. And we're going to take baby steps. Just like in any software development cycle, we want to start with the basic functionality, and then we want to add one feature at a time until we have the full thing up and running. So while we would start with a replica of version 1 using ADK, all right, which ultimately will give us something that's more maintainable and more robust to build on top of, right? Then we can then start breaking out the workflow a little bit, changing it around so that we can add additional functionalities, such as my laptop just froze. Folks, So what we're going to do is we're going to use some prompting techniques to create a faithful replica of your existing agent in a way that works with ADK. Okay, so let's go ahead and just kind of build a prompt that does this. What's your first instinct? How would you phrase it?
I would just describe what we're trying to do. So I would just start typing and say, I need to port this over into ADK, create a plan to do this, and see what it comes up with, and kind of just go step by step.
Beautiful, that's exactly right. The idea of creating a plan is vital. We don't want to just start coding without having at least an idea of what the agent is going to do for us. And we're talking about the coding agent right now, not the titanium agent that Jacob is building.
Something I learned, I always now add in, then re-verify your work. Make it go back a second time, because it catches things that it misses.
Now, I notice that as your agent is beginning the planning process, it's saying, I analyzed skill.md. The ADK team recently released a set of ADK dev skills that can work with a wide variety of coding agents, not the least of which is Antigravity, but also works with Gemini CLI, Claude Code, and a wide variety of other agents that teach the agent the coding agent, how to develop ADK applications, right? So yeah, so that's what it's doing. Now I see that it is displaying a plan. Let's take a look and scan that plan. So I see it's going to generate an agent, verify the agent, use a pipeline.
So it looks like it's taking the functionality in my code and just creating agents for each of those tasks that I would have Gemini do, for example.
Yeah, and it's proposing wrapping them together in what's called a sequential agent, which a sequential agent then executes steps 1, 2, 3, 4 in sequence. That's in the name.
Got it.
So
I'm going to start.
Yeah, so go ahead and you start coding. In parallel, what I'm going to do is I'm going to create a crawler. So the intent here is that we're going to crawl a particular website. So I'm going to say create a crawler that uses, and I've installed Playwright, which is a headless browser automation software. Uses Playwright CLI. All right, while that's happening, I'm going to start getting a couple other things ready so that we can accelerate our development, because I'm sure Frank is looking at me, giving me the eye.
And I'm making progress here. It's building out the new code in ADK. And this is still Python code, which is great.
Excellent. And at the moment, everything looks good. I'm just going to remind it, there's a .env file with the necessary variables to connect to GCP and application default credentials. All right, so it's progressing.
Great.
Right? Little hiccups that you're finding are natural. They're going to happen.
Okay.
Frank, dare I ask, do we still have time?
Perfect timing, Luis. You have 20 minutes left.
Okay, no pressure.
Yeah.
All right. In the meantime, I am observing that my coding agent is actually, it started crawling. So looking at the terminal output, you see here where it says clicking show more, right? So if we look at the actual website, notice this. This is the website that we're crawling. There's a search box on the top. And then there are roughly 12 case studies that it shows, and then the show more button, right? So there they are. So if I click show more, it shows me another 12, right? And another 12. So what's actually happening right now is that the agent developed a tool that goes to the website and it's actually manually clicking, right? That's cool. That button and figuring out the links to every single one of these case studies. And once we have the links, we can then download them all, right? That's pretty darn cool. And so we can start moving on to the next step, which is that we're going to take this ingested data, or this downloaded data, and we're going to start figuring out how to write it to a vector database. And to write it to the vector database, we need to first create it. And so I can see already that the agent is trying to figure that part out. So we'll let it do that on its own. Okay?
Got it.
Yeah. So we're doing really, really well. /agents. That's
10 minutes, folks. 10 minutes.
Oh, come on! All right, so we are inside the project. We have improved agent. We have a root agent declared here. This is exactly right. What I find interesting is that it did a slightly different approach than I would, but that's correct. It's just, once again, slightly different. Key thing is that it's declaring a root agent, and that is what we care the most about.
Great.
Okay. All right. In the meantime, I think we got to start getting ready to push your code actually and give it to me. There it is. This
And then time is up. Hands off keyboards. Off keyboards.
Down to the wire.
Indeed.
I was a little more confident. I thought we were gonna get this done in about 30 minutes.
Yeah.
But there's always little things that go wrong that you have to work through.
I think the problem is I talk too much. So, all right. Do you want to try to see if this works?
Let's give it a shot.
Type it in, sir. You do the honors.
Let's see how this works.
Give it a spin.
All right, a simple prompt, a short prompt, just basically targeting the company and the role. And with that information, we start seeing what's happening. Oh my gosh. So it's actually running a bunch of Google searches.
Wow.
If we kind of click here, we can mouse over and says, execute a search for current CTO of the company. We should start seeing some results in here. So these are the different function calls. You look at all these different searches, right?
Yeah.
So it's executing the searches, and then it's consolidating the response.
Yep.
The initial response. So this is the initial research on the company and what their priorities are, right? And then it's executing vector search.
Yeah.
But what you're seeing here on the side, these are the case studies. So as we kind of scroll down, we start seeing then the consolidated list of case studies that have been selected as the preferred ones. And then finally, we start generating your final punchy email. What do you think?
This is awesome. I mean, taking it from a tool that I'm using as really a pilot into now something that's much more production ready, scalable to my team. I'm much more confident talking about ADK and these tool sets with my customers and partners. The accuracy and value that this can bring now, having a vector database really up and running in a meaningful way, it's incredible. Thank you.
Well, thank you. And this brings us one step closer to bringing this project to production.
Let's pause this right here. We forgot one critical thing that would make this agent production ready. Can you guess what that was? It's the user interface. This is what the new user interface would look like, allowing us to enter the target company and their domain. Once we get the research complete, we can copy paste it and send it off.
What's next? Well, we're going to put some polish on the code, make this all readable and easy to understand. We will also author a blog post. So you can find links in the description to the fully finished code, the ADK project, and a blog post about everything that we covered today. So thank you so much for joining us. And thank you, Jacob, for joining us. And we'll see you next time on the AI Agent Clinic. Well done.
Nice. That was great.
Very good. Let's get back to work.
Well, Luis did great today. He clearly was very clear with his approach, and he's like a teacher. You know, he explained the concept really clearly, and he's very patient. But you know, he did spend 20 minutes before actually start coding and building anything. And so my advice to the future host is trying to get to the production building phase quicker.
Indeed, I probably talked too much, but we're back. It's so great to be back with you after that first look at the AI Agent Clinic. Thank you for chatting, by the way, and asking your questions. Jacob, I have a question for you. Have you recovered from all that craziness?
No, that was so much fun. Yeah, Luis, I'm still hanging in there. I have to say the energy in the chat, it's been a lot of fun. Really fantastic. I've loved seeing tons of questions coming in, comments, a lot of support. And a lot of the questions I actually had myself. So it's nice to see I'm not the only one.
Yeah, well, it's now time to pull back the curtain. So we're going to move into our technical deep dive to unpack a little bit more detail as to how we built and broke and deployed this agent. So Jacob, why don't you take it away?
Yeah, perfect. And I've already started pulling together a couple of questions from the chat. Let's jump into the first one.
All right.
In the video, we see the agent figuring out the vector database ingestion, but we don't get to see the actual build. How exactly did you architect the vector store behind the scenes? Did you use a managed service like Vector Search or a local instance like ChromaDB? And what was your chunking strategy for those case studies? So there's a lot of meat here, Luis. Maybe start with a simple explanation.
Yeah, absolutely. So indeed, we did not have too much opportunity to dive into what was developed. So let's talk about that. The vector search engine that we use was Google's vector search, specifically the 2.0 version that was released in the last month or two. And this README that you're seeing here is actually what the development agent that I was using created as it was planning the process, right? And so what we did is that we first needed to create a crawler that could crawl a specific website, and then that crawler then needed to, one second here, that crawler then needed to be able to actually retrieve the content from the website. So, so this happened in two phases. First, we go to the website that we were crawling, and that's this one here, and we needed to extract the URLs of all the different case studies that were there. All right. Once we had a list of URLs, then we would go through a content extraction process where we would grab the HTML from the specific case study and create a markdown version. So that was a two-step process. Once we had a markdown version, then we stored it inside the Google Vector Search database. I could have used, and we could have used a locally installed vector store such as ChromaDB or Pinecone or any of a myriad of other similar services out there, but we chose to use the Google Vector Store. All right. So once that happened, then the next part comes in, right? We've crawled the data. We have stored it inside the vector database. Now we need to expose this to the agent. And so we exposed vector search functions to the agent that allows then for the content to be read and then processed and presented to the user. So let's actually look at that code very quickly here. This is the crawler, right? And the crawler, as I mentioned, executes in two phases. First, discover the different URLs, and that's what you're seeing here. And so it would load a page. It would then kind of click on the more button while grabbing all the URLs that were present there. Once it found those URLs, right, it extracted them. That's what you're seeing here. And they got stored in memory, right? And then saved to a file. And that's what you're seeing here, right? So the URLs are now stored. Now we can then move on to phase two, where we extract the actual content from the pages, right? So we would fetch the contents of the individual URLs. And then in here, what's cool is that we're using Gemini itself to pull out the content, reformat it, and prepare it for insertion into the vector store. So this is the model call, just using the regular Gemini SDK client, right? And once we received our response, which we used JSON conversion, right, that's built into the SDK to format it in a structured fashion, then we went ahead and then we inserted that into the actual vector database. So once that part is done, then we can move on to the actual querying. But let's take a look at the output generated by this crawler, right? So here's a list of URLs, and we've got 1,600 or so links, right, that were extracted by this crawler. And then that in turn pulled out the content. And so we have a very large JSON file containing all these different case studies that were pulled out from those pages, right? So now we've done that. It's in the vector database. We need to be able to query it. So a little later, perhaps we'll show you what the agent looks like and how it searches. But ultimately, this is the function that works the magic, right? In this particular function, what we're going to do is we're going to take a query string and we're going to pass it along to two searches, right? So we're going to execute a semantic search, right? And then we're executing a text search, and we're going to combine those results. All right. And the reason for this is that it's actually something we were discussing in the chat just a moment ago, is that sometimes you might need to do a hybrid search, right? And this is a great opportunity to take advantage of those capabilities. And we'll show you a little bit later, perhaps, how we take advantage of these two different types of search results. So yeah, once we get those results, we will combine them and re-rank them, right? And then we present them to the agent for the agent to then present that to the user. All right, what's the next question?
Awesome. Yeah, thanks, Luis. So this one comes in from Dan here. He says, what's the benefit of using ADK versus the original version that I wrote, that Jacob wrote? Can you compare the ADK version against the original?
Yeah, certainly. So let's do a little side-by-side for that. Okay, so let's go back to the screen share. And here, we on the left-hand side here, we're going to see the original agent that you developed. And then on the right-hand side, we're going to see how that is expressed in ADK. And so let's kind of look at the original version first. The original version uses the regular oops, that's the wrong function. This is the function. Here we go. The original version uses the just the regular Python to create the orchestration flow, right? And so we look in here, we have a function called process account, and you call a function called generate intel, which actually goes and researches a company. You have a verification function that gets called, right? All wrapped inside different if-then statements and loops and so forth and so on, right? And so you've orchestrated it using these nested if statements, right? And so that's fine, but we can express that far more succinctly if we use ADK constructs. So ADK is specifically designed to make it easy to develop these types of workflows, right? These types of step-by-step processes. And so what you see here in the highlighted section is a representation of your agent, right, as expressed by ADK. And what you can see here is that we have this concept of a sequential agent. That sequential agent is capable of executing steps in order. So this is the same steps here, such as research the company, which is analogous to your generate intel function, right? Your case study researcher, which in this case is how we injected the new functionality where we actually look for real case studies as opposed to using the hard-coded ones, right? And then we draft an email. So you can see it's succinct. It's also extensible, right? Because you can imagine now adding additional functionality just by adding it somewhere in this list, in this sequential list. And in fact, that's what you see up above. Think of this as an advanced version of your original agent that does a little bit more. It still executes the company research, but then it also executes a plan. And the plan, think of it as kind of like adding a little bit of forethought and planning to how we're going to craft, how we're going to research the case studies, how we're going to craft the message. And that is then going to be leveraged by the case study agent. And we added another agent called a selector agent, which will look at all the results that were returned by the vector search tool. And it will select one, maybe two case studies that are most relevant. Why is that? Because your use case required sending a very punchy email. You don't want to generate a message that's 3 paragraphs long. You want to respect the executive's time, right? And so sending a very short, punchy email is important there. And so that's essentially it. Now, when we look at a little bit further above, and we're just going to look at one function here that I think is kind of captures the bulk of this functionality, right? And that's your original researcher here, right? So let's do a side by side. And we're going to do that there, and we're going to go here, right? So this is the ADK version on the right-hand side of your generate intel agent. Here, it looks very similar. The prompts are very similar. Look at the steps. The objectives are to scour the internet. That is repeated here on the right-hand side as well, right? It's going to do the deep research. It's going to identify the industry and so forth and so on. So the prompt is very, very similar, but a couple changes. One thing we don't do on the right-hand side is that we don't specify a JSON schema in the prompt. Okay, in your original agent, you were providing a JSON schema. Here, we don't do that because in ADK, we can actually supply that schema as a value. Okay, and so as you can see, the actual code part is much more succinct, much more readable and maintainable and extensible than the original version. Here you can see that your agent was doing a lot of like regular expression matching and so forth and so on. So it would be harder to maintain over the long run. So that's why it was important to not just add the superpower of vector search and case study searching and crawling to your agent, but also refactoring it to use something that is much more purpose-built for creating agents. So hopefully that answers the question.
Yep.
What's next?
Great. Okay, the next question here. Agentic loops can burn through tokens incredibly quickly if they get confused or hit an error. How do you prevent the auditor agent from getting stuck in an infinite loop if it continually struggles to verify a specific technical claim using search?
So First, I really cannot think of a scenario where an infinite loop would occur, and the reason is pretty straightforward. ADK itself, when we do something like invoke an LLM or do, in this case, the vector search or something like that, there are constructs and parameters already in existence that control how many times the agent will retry a request, for example, right? And so those limits are built in and they exist. There's not just a retry limit, but also a timeout limit, so that if you issue a request against a remote server, we're going to wait up to a certain amount of time for a response to occur. This is standard development practice, right? This is standard software engineering, and the ADK already encapsulates those types of capabilities. When it comes to predicting costs, controlling costs and avoiding runaway costs, that is a very relevant question in this world of LLMs where you're paying by the token. I encourage developers to look at their prompts and focus on prompt optimization. And while maybe I would not recommend obsessing too much over token efficiency, one should at least be thoughtful about it, right? And be able to ensure that their use of tokens is reasonably efficient, right? We don't have to go all the way overboard, but let's think about what the minimum amount of information an agent and the LLM might need in order to provide a contextually relevant response. So as I mentioned, we have ADK that gives you all these kind of capabilities out of the box in terms of retries and so forth. It gives you exponential backoff. It also includes, when it executes like a fan out, each of these sub agents has its own time limits and retry limits. So it's going to execute in a finite amount of time, and therefore we're going to avoid infinite loops and avoid runaway costs.
Yeah, and actually, Luis, you brought up the next question really effectively. Oh, yeah? There's another one here that asks, you use the fan out pattern with ADK to research multiple target companies in parallel. When dealing with asynchronous multi-agent orchestration, how does the router handle race conditions? What happens if one of the worker agents hangs while the others finish? A great question.
Yeah, in some respects, I answered it previously, because if something hangs, it eventually times out and the ADK will terminate execution, right? However, there's still more in here that we can kind of tease out. So when you're race conditions, let's talk about that, right? This is the way that this particular implementation worked is that we will execute multiple searches in parallel, and then we're going to save the results into a shared data structure, a variable. And in this particular case, we can apply standard development practices here to avoid race conditions. But at the end of the day, we have an in-memory object. It's a Python dictionary, right? Or actually a Python list in this case. And we're just appending. And by using an append function, we avoid a race condition. We're not having multiple agents, or I say sub-agents, trying to write to index number 3 at the same time. They're just appending their results to a list, and therefore you can avoid that. But yes, otherwise, feel free to develop and use standard practices like locks and semaphores and so forth to address any potential concurrency-related issues that you might encounter when you're having parallel tasks executing at the same time.
Great, thanks. Okay, another question here. Setting the temperature to 0 for the fact checker agent is a great move to enforce deterministic output. But what happens if the search tool returns conflicting information about a company's tech stack? How does the agent resolve ground truth disputes?
Yeah, so the agent in this case, first, it did employ a re-ranker, right? And the re-ranker helps, I'm going to say, sort through the results. But let's kind of focus on the last bit. How does the agent resolve a ground truth dispute, right? If your data set is, I'm going to say, imperfect contains contradicting information. So for example, there might be, your data set might have a statement such as the sky is blue and another one saying the sky is purple, right? We have a problem with the data set, right? And so what I would suggest employing here to avoid things like conflicts and whatnot is to instruct the agent through the prompt to either disregard conflicting information. That is to say, acknowledge the fact that we have two potential facts that are in conflict with each other and might be difficult to disambiguate them, right? And so therefore we might want to just ignore them altogether, or to call it out or do something else. My point here is handle the exception somehow, right? You want to identify that an exception occurred, and you can do that. You can start doing that with prompting. Okay, you can implement other kinds of safeguards as well, but also look at your underlying data. If your underlying data is dirty, I say dirty, but it's inconsistent, right? And it contains these potential factual errors, then we might want to clean up that data to begin with. Beyond that, let me see what else. We can also rely on the model itself to try to disambiguate on its own. So all large language models are effectively, as Andrej Karpathy might say, they're very lossy compression of the entire internet, but they contain facts, right? They have they've been trained with the contents of the internet, and there are facts that are captured inside the model weights. That means that it's feasible, it's entirely feasible for the model to disambiguate on its own, because it knows that the sky is blue, not purple, except perhaps under a very beautiful sunset or something like that. So that's kind of the idea there. So hopefully that helps answer that question. What's next?
Awesome. Thanks, Luis. So, okay, another one here. Debugging non-deterministic agents in production is a massive headache. Yep. Now that Titanium is off the local terminal and running in a decoupled ADK architecture, what does the observability stack look like? Yep. How do you trace exactly why an agent made a specific decision?
Yeah. So observability is critical, right? Being able to understand what any code base is doing, let alone an agent, is absolutely paramount to ensure that the agent is operating in a predictable, reliable, and performant fashion. So where do we start? Tools like ADK give you observability out of the box, and it starts at the developer workstation. So when you're developing an agent using ADK, you have essentially a built-in chat app called ADK Web that you can use to inspect the variables, right, and inspect the flow of the agent. And that in and of itself is very, very powerful and gives you that insight as to what the agent is doing, what data it's receiving, and so forth. You can also implement step-through debugging, right? So this is standard development practice, right? Run your agent inside a debugger and step through it, right? And look at the variables, look at what's happening. You can use that to identify potential timeouts or even potential race conditions and so forth. So that is also a very, very good practice. Finally, virtually every agent toolkit that I'm aware of, whether it's ADK or others such as Crew AI and so forth, have observability built in. And observability primarily through OpenTelemetry support is the most common thing that we see. So you can enable OpenTelemetry, take the traces and store them in a centralized location, whether it's Google Cloud's operations suite or a third-party service, and you can use that information, especially now that your agent may be deployed to production, where you can go ahead and observe its behavior. You can also set alerts, right, to ensure that your agent is adhering to any service level objectives that you might have set, and ensure that you're providing a high quality service. Hopefully that helps. What's next? Are there other questions?
Yeah, we have a couple more here. A
Excellent.
few from Philip. Let's get to these ones. And thanks again for the questions, team. Really appreciate it. The first one from Philip: how did you guys trigger the crawler?
So the crawler was a one-time task. So there's just a separate function that that dealt with the crawler. It lives outside of the agent, right? It is the kind of thing that you might want to run, say, once every 24 hours or once a week, right? So it's a standalone tool. It does not really require any sophistication in terms of agentic behavior, other than the LLM-powered content extractor. So that's how it was triggered. In this case, I was using a development agent, right? So the code agent was triggered the execution, but it's its own standalone thing. And when we share the code, you'll see that crawler implemented there.
Yep. And second question from Philip: do you always start by default with a classifier agent? And sort of with that, what would be the core few points for deciding how to isolate agents with respect to latency and with respect to task?
I'm not sure how to parse that question entirely, but at a high level, no, you do not always start with a classification, or in this case, I had introduced the sophisticated version of the agent included a planner. A planner is good when you're doing research or when you're completing a task that has a non-deterministic kind of workflow or process associated with it. So generically, like if I zoom out a little bit, generally speaking, I think what we want to do is just look at the type of process we're trying to implement. If it's a very structured process where we know it's like step 1, step 2, and then at step 2, we make a choice to go to step 2A versus 2B, right? And so forth. If it's a very discrete, well-known workflow, then you might not need planning or optimization or anything along those lines, right? But if it's a more loose kind of a process where there's a lot of judgment that might come into play, then maybe some degree of planning or something analogous might be valuable. So just look at the use case. I encourage you to experiment, right? Don't be afraid to kind of go down one route and uncover that maybe it's not the most optimal path, right? That's first of all how we learn, right? We learn by experimentation, by doing, and we learn most when we make mistakes, right? So please, don't be afraid to do that, right? And take those learnings and apply them to the next iteration of whatever it is that you're developing, whether it's an agent or some other application.
Yep. Thanks, Luis. And I think this is the last one here. This is from Osvaldo. Can these agents be combined into an N8N workflow? Yeah.
So N8N is actually a really cool workflow tool. It has a visual workflow builder, and so it can execute these processes. It supports LLM integration, and indeed, you can expose an agent built in a different framework, whether it's ADK or LangChain or something else. You can absolutely expose it as a node in the overall workflow. So absolutely, you can do that. It's not very challenging at all. All right.
Great.
Well, I think we're going to wrap. So we're here at the end. I want to thank you, Jacob, for being the first guest and guinea pig on the show. So many thanks to you and the audience for joining us at the Google Cloud AI Agent Clinic. We will be posting a link to a GitHub repo in the description, so please keep an eye out for that. We'll also be publishing a blog post with additional details summarizing everything that we've learned while upgrading Jacob's Titanium agent.
Yeah. No, and thank you, Luis. It was so much fun. I learned a ton. We made some massive improvements. To everyone on the live stream and in the chat, thank you for participating and engaging and asking all these questions. We also want to hear from you. So there are so many different ways to build these agentic workflows. Let us know in the comments how you would have fixed Titanium, what architecture changes you would have made, perhaps how you would have done things differently.
Yeah, indeed. There's no single right way to do this. Now, we have a special invitation for you. Are you building an agent and are you hitting a wall? Do you want to bring it into the clinic and upgrade it with a Google expert? Well, I want to see what you're working on. So get in touch with us. Tell us about your project by emailing agent-clinic@google.com. In the meantime, thank you so much for watching. Please keep on building, and we'll see you next time on the AI Agent Clinic.